Hey class, so this will be the first ever video on the requests that you guys had made last term. So yeah, we're going to continue the topic of surface area and volume. And the next lesson that we're going to look into is surface area of pyramids. Last term, we talked about surface area of prisms, and it'll be taking the skills from that surface area of prisms and using it in surface area of pyramids. Okay, let's get started. So, surface area of pyramids. One method to find the surface area of a pyramid is to examine its net as well as the sketch of the pyramid. And we'll look into that in a couple of examples. So on the left, I have sketched a pyramid, and I have drawn this dotted red line down to the base of the pyramid. This is called the perpendicular height. This will be very important for you to understand what the height or the perpendicular height of a pyramid is. It starts off from the apex, which is right at the top here, down towards the base. Okay, so hopefully that kind of makes sense to what a perpendicular height is. Then on my right, I have drawn the net of the sketch of the pyramid on the left here. So this is a net of a pyramid, basically consists of basic shapes that we know the area formulas to. So for example, triangles and a square. Okay, so those two things are two methods that we will use to figure out the surface area of a pyramid. First example, find the surface area of this rectangular pyramid using the dimensions shown on the net to the nearest centimeter squared. So one strategy that I'm going to pass down to you is whenever you start reading the question, I want you to use a different colored pen, and I want you to highlight different things, I guess the keywords in the question. So for example, the keyword is surface area, because that's what we're trying to find, as well as rectangular pyramid, right? Rectangular is a keyword because it tells us what the base of the pyramid would be, which is a rectangle, as well as at the very end, I want it to be calculated to the nearest centimeter squared. Centimeter squared, would mean that you're converting or rounding it up to the nearest whole number. Okay, that's how I would like you to remember nearest centimeter squared. So let's get started. This is the net from question number 1. It's given us. Now, another strategy that I'm going to tell you with dealing with surface area of a pyramid is labeling your net, as well as if you look here, I had highlighted that this is a rectangular pyramid, meaning that the length and the base, or the length and the width, would be different, right? We've got a length of 11 centimeters and a length of 18, meaning that the triangles would be different. So what I normally would do, if you haven't seen here already, is label one triangle as T1 and another triangle as T2, right? It's just for me to differentiate and make it my life easier when solving a surface area. So start off with strategy is surface area equals to area of what is the base of the pyramid. We said it was a rectangle plus the area of, we've got two different types of triangles. So I'm going to write down area of T1. There are two triangles that are exactly the same as T1. So I need to multiply that area of T1 by 2. Plus the area of T2 triangle. There are two of those, right, on opposite sides. That's right there. Another strategy that I would like you to use is first, if you don't remember your area formulas, write it down. So the area of a rectangle is length times breadth, plus the area of a triangle is half times base times height, times it by 2, following the exact same formula that you did at the top, plus Again, another area of a triangle. Let's just copy that down from the previous one. Okay, there's our formulas. Now what I need you to do is substitute. So the length of the rectangle is 18 times 11 plus half, which is still a number, so just bring it down, times it by the base of T1, which is 11, times the height, which is 15.7, times it by 2, plus area of T2, half, times the base is 18, times 14, times it by 2, because there's two triangles. Put that all into your calculator, and you should get 623 centimeters squared. It's centimeters squared because we are talking about surface area. All right. There you go. All right. It's nearest centimeter squared, round it to the nearest whole number. Okay. Whole number meaning there's no decimals. Yeah. That's example number 1. Pause if you need to look back on that, but I'm going to move on. Question number 2 is find the surface area of this rectangular pyramid to the nearest centimeter squared. So here in the red, I have said that this example is to show how to use the perpendicular height to calculate the surface area. So the perpendicular height here is the red dotted line, which I have labeled as 15 centimeters, right? The length of this rectangular pyramid is 16 by 12, right? Now, to figure this out, again, step number 1, draw a net, right, and label it. The length and breadth of this rectangle is 12 and 16. Now, there's a few things that I'm missing, okay? So I'm going to label it. Before I do that, I'm going to label which one is T1 and which one is T2, right? Two different triangles of different bases. Now, one thing I'm missing is, I know the perpendicular height, but I don't know what the height of, I guess, T1 and T2 are, right? I don't know what this length is. So what I'm going to do is, as mathematicians normally do, I'm going to label it as a letter or a pronumeral. I'm going to label this height of T1 as Y, this height of T2 as X. So we've done that. Okay, now we're going to look back on that in just a second. Step number 2 is find Y and X, meaning find the height of the actual triangles, right? So find the height of the triangles. Well, looking at the net, we don't know what this slant length is. So we can't use that. So let's look at our sketch, okay? We look at our sketch. We have only been given a particular height. What I want you to see is, looking over here, this height or this length is 16 centimeters, as well as if it was here, this is 16 centimeters as well, right? So what I want you to do is try and draw a line here, right? And then the Y of T1, right, is on the face of the triangle in this pyramid. So I want to label this as Y, right? That's what we're labeling here. Yeah. So this is Y. What is half of 16? Half of 16 is 8. The perpendicular height is 15. So we've got two informations to figure out what Y is, right? That's enough. So let's try and label it. I've drawn my triangle for T1. We said that the whole of this is half of that centimeters, right? Then my perpendicular height was 15 centimeters, and we wanted to figure out what Y was, right? How we're going to figure this out is using Pythagoras' theorem. I put the formula here if you don't remember what it is. C squared will be our hypotenuse, which is y squared. Let's substitute that in. Our a squared will be our 15. Then our b squared will be 8 squared. All right, let's start doing it. So y squared equals to 15 squared plus 8 squared, which we will get in our calculator as 289. Okay, how do I get rid of the square root? Oh, the squared is to use the square root, which we will get as y equals to, putting that into your calculator, y equals 17. All right, I'm going to put that as a box so that I know that this will be our y. Let's do the exact same thing, right? Looking at our net, T2 is the length of 12. Half of 12 is 6. Use the exact same method that we used in T1. We're going to use our perpendicular height because that's the only thing that we know. We don't know the slant height. And we'll put x as our hypotenuse. Same thing. This will be as x squared equals to 15 squared plus 6 squared, which will equal to, if I put this into our calculator, 261. X will equal to the square root of 261. Oh, 216, sorry. I'm going to put it as a square root, right? You can put it into decimal if you would like, but the thing is, I would rather round it at the very end than right now, because sometimes you can come up as little mistakes. So we've got what our x is. Let's do our surface area now. We've got all our information. Let's do it. Again, writing down what our basic shapes are and how many they are. Then writing our formula. Then now we're subbing it in. The length and breadth of this rectangle is 12 times 16 plus half times the base of T1 is 16 times the height we found as 17. Times it by 2 plus half times base is 12 and our height was square root 2, 261. Right. Apologies here. It should be 261. Times this by 2. Put that all into your calculator and you should get 655 centimeters squared to nearest centimeters squared. Okay, that's our second example. Our third example is find the surface area of this rectangular pyramid. Right, this example will show how to use the slant height. Right, this is our slant height or slant length. Right, our slant length in this particular question is 12 centimeters. Again, going back to our steps, step number 1, draw a net and label it. I've drawn it, I've labeled it, labeled which one is T1, which one is T2. Now, the slant length will be this here, right? This part here, this is our slant length. Each slant length will be exactly the same in each triangle, right? Again, I don't know what the height of each triangle is, so that's what I'm trying to figure out. This comes to our step number 2. What is y and x? Let's start doing it, right? Looking at our triangle for T1, right? The base length is 10. Half of that would be 5 centimeters. The height is something that I do not know, which I'm going to label as x. And my slant length here is 12 centimeters. Again, let's put it down. Our C will be our 12, right? Because that's the hypotenuse, equals to x squared plus 5 squared. Again, I'm just going to write down what 12 squared is, which is 144 x squared plus 25. I want x squared as the subject, right, by itself. X squared equals to something. I need to do 144 minus 25, right? That's how I'm going to move the 25 to the other side. So that's it. What we'll get is square root of 144 minus 25, which you will get as square root as 119 centimeters. That's our x. Yeah, it's pretty easy. Now that is our x. Let's go to our triangle 2. Triangle 2 will be y, 4 centimeters, right? Because this is our 8 centimeters here. 12 centimeters over on this side, using the exact same strategy. 12 squared equals, well, in this case it's not, y squared plus 4x, or 4 squared, 144 equals to y squared plus 16. Y squared equals to square root of, sorry, y will equal to the square root of 144 minus 16, which we will get as square root of 128 centimeters. Okay. Once we've gotten that one, step number 3, again, do the exact same thing. Length and breadth of the rectangle is 8 times 10 plus half times the base of T1, which is 10, times our height of T1 is square root of 119, times it by 2, plus half times 8 times square root of 128, times it by 2. Put that all into your calculator, and you should get 280 centimeters squared, 2 nearest centimeters squared. So that will be the last and final example. Pause and play as many times as you want. Write these notes down if you would like. And yeah, this will be our first video, and I'll see you in the next one. Bye.